Okay, so we are going to check these out. I'm going to get a piece of paper out because I'm going to need some extra space. You might too. We are solving each of these systems. So let's go ahead and look and see what happens. So remember, when you're solving a system of 3, you need to be consistent about which variable you are making disappear. So I want to have my z's go away. The reason I chose the z is I can see that these two will make them disappear, and then when I put these two together, it will also make it disappear. So that makes me happy. So I'm going to put these two together, and I'm going to get 2x and 2y, no z's, is equal to 4. And then I'm going to put these guys together, and I get 3x plus 3y is equal to 6. And now I need to have something disappear again. So I'm going to multiply this guy here. Look at this. I'm allowed to multiply by the same thing or divide by the same thing. So I began looking a little bit closer at that and went, 2, 2, 2 goes into both of those, 3, 3, 3 goes into both of those. So I'm going to simplify this one by dividing everything by 2. And I'm going to divide this one by 3. What do you notice? These two guys here are exactly the same. So if I subtract it, I get 0 equals 0. So what this means is that there is an infinite number of solutions. Also, what it means is that this guy here is how they're combined. So if I plug in like a 7 to get here, I can go ahead and solve for what the y would be. If I plug in a 12 for here, I can solve for what the y would be. So there's an infinite number, but they are all on kind of one line as you're going there. All right, cool. Let's try the next one. The next one here, again, the first thing I have to do is decide which variable I would like to eliminate. When I looked at it a little closer, I kind of like this one, the y's, because these guys will be able to eliminate without really doing any extra work. And this is a negative and a positive, so if I just multiply that by 3, that should work out well. So I'm going to do that. I'm going to go ahead and put these two together. And then over here, I'm going to very carefully multiply through by a 3. Now, most of the time, hold on. Most of the time when I find mistakes with students, it's not that they didn't know how to do it. It's that they made a little mistake. So first, if you notice, I was real quiet as I did that, and I checked my sign, I checked my sign, I checked my sign. 0 times anything is 0. I check that. I'm very careful. And then I'm very careful to write the next part as well. It is all about precision. It is all about not making a tiny little mistake that ends up being huge by the time that you're done. So now, awesome. I was trying to get rid of the y's and that happened. So I end up with this. Now I'm going to go ahead and put these two together, but what I need to have happen is I need one of them to disappear. So I want the x to disappear. So if I multiply through by a negative 3 everywhere, careful. I have found that I cannot talk about, I can't even say the same thing as I'm doing because I can make so many tiny little mistakes along the way. So I just have to be very, very careful. I check the signs, I double check my multiplication. Be very, very careful as you go through here. Those will cancel, those will cancel. Now, is that true? Is 0 equal to 9? Hopefully you're saying no. And so that means there is no solution. So what is probably happening here is we have like a plane and another plane, and they're like parallel to each other. So that is why we don't have anything that is intersecting in those guys. All right.